Today we're going to look at adding and subtracting rational expressions. Our objective is to be able to simplify rational expressions and to be able to simplify rational expressions that include adding or subtracting of each other. What must be true in order to add or subtract fractions? Well, hopefully you remember this, but you must have a common denominator. So any fraction that you want to add or subtract together, you have to have the denominators be exactly the same. It means all the same factors. So let's look at a problem that you'd probably dealt with a long time ago, well before high school. 2/5 plus 3/25 minus 1/10. Now, in order to add these, you have to have all the denominators the same. So what number could we make 5, 25, and 10? Now you might be able to look at this and think, well, I can make 5, 10, or 15, or 20, or 25, because remember, all we can do is multiply our numerator and denominator by the same value. 25, we could do 25, 50, 75, and 10 could be 10, 20, 30, 40, 50, and so on. So we want to find a number that's common, and we want to find the smallest number to make our simplifying easier in the long run. Well, if you look at these, the common number would be 50. But if you didn't know that, I'm going to show you a little technique that could help you do this a little bit easier, especially if the numbers are a little bit bigger. So let's look at our three denominators, 5, 25, and 10. Let's write down its prime factors. So that means if we break down this number into its prime numbers, well, 5 is a prime number, so 5 just becomes a 5. 25 can be broken down to 5 times 5, and 10 can be broken down to 5 times 2. And I'm going to write anything that's not the same on its own column. So if I look at this, my least common denominator, all three of them need a 5. The 25 needs a 5, and the 10 needs a 2. If I write down all of the things that they have in common and anything that an individual term might have, 5 times 5 times 2 is 50, and this is what we call our LCD, or least common denominator. I'm going to use this to rewrite all of my fractions with a common denominator of 50. So if I look at 2/5, in order to make that 5 of 50, I need to multiply by 10. So 5 times 10 is 50, so 2 times 10 is 20. And again, if I reduce this, I should get back to my original. Plus, 25 needs to be 50, so 25 times 2 is 50, which means 3 times 2 is 6. And then 10 times 5 is 50, which means 1 times 5 is 5. Now that they have a common denominator, I can rewrite my denominator and I just worry about the numerator. 20 plus 6 minus 5. And again, we work left to right. 20 plus 6 is 26. 26 minus 5 is 21. So I get 21 over 50. Now I look to see if there's anything that I can reduce. There's no common terms or common factors in each, so my answer would be 21 over 50. Now, a lot of you would not go down and do this step, but this is a very vital step when we deal with polynomials, so I wanted to show you the continuity of what we're going to do today. So now I have denominators with x's, so we have some polynomials here. They're a little more complicated. We have x, x squared, and 2x. So again, what is our least common denominator? So if you can't tell by just looking at it, let me show you kind of how to do it with our factors. In 2x. So again, x is just x. X squared is an x times an x. And 2x is an x times a 2. So again, they all need an x. This one needs an x. This one needs a 2. So my least common denominator is 2x squared. Again, what this means is I can make each of these denominators equal to this by multiplying it by one or more things. So let's look at my first fraction. And I'm going to rewrite this one out just so you can see a little bit more. Okay, plus 3 over x squared. I'm just going to write it with a little bit of space. Alright, so I need to make each of them 2x squared. Well, this is an x, so I'm missing a 2 and another x. So I need to multiply the top by a 2 and an x. I have an x squared, but I'm missing a factor of 2. And the last one is a 2 and a single x, so I'm missing a factor of another x. Okay, so now all of them have a common denominator of 2x squared. And now I just worry about the numerator. 2 times 2 times x is 4x. Plus 2 times 3 is 6. Plus 1 times x is x. So my final answer would be 5x's plus 6 divided by 2x squared. Now I can't factor or do anything with my numerator. And again, from what we did in our simplifying, you should remember that you cannot start just crossing things off and canceling, because I can't factor. This would be my final answer. 5x plus 6 divided by 2x squared. In our third example, it's a little bit more complicated, and since we're not just dealing with a single term, okay, we have a trinomial and a binomial here, it's going to be a little bit different when we talk about our factors. And I'm just going to keep it the same way I did before. You won't have to always do this step, but I just want to show you what's happening. If I take that trinomial and factor it, I'm going to get an x, let's say, plus 2 and an x minus 6. Okay, 2 times negative 6 is negative 12, and when I add, I get negative 4. And if I break down x squared minus 4, it's an x plus 2 and an x minus 2. So what would my least common denominator be, my LCD? Well, they both need an x plus 2, so we just write it down once. I need an x minus 6, and I need an x minus 2. So that's my least common denominator. So, well, let's think about this. And I'm just going to write the factors up here, and this is what most students will do. But if you struggle, you can always write what I have down at the bottom. Okay, that's how each of those factor. So I know they both have an x plus 2 already. I have an x minus 6 here and x minus 2 here. So I know that this first fraction is missing an x minus 2. Okay, so I would need an x minus 2 and a factor of an x minus 2. The second fraction has the plus 2 and the minus 2, but it's missing the x minus 6. So the numerator would need x minus 6 as well. So now that I have my common denominator, we leave it factored. Okay? You don't need to do any distributing or multiplication. Okay, so I'm going to write my common denominator, and now my numerator is x squared times an x minus 2 plus a 7x times x minus 6. And now I'm just going to do a little simplifying. I'm going to keep, again, my denominator exactly how it looks. And the order that you write these doesn't matter. It doesn't matter if the x minus 6 comes first, then the x minus 2, then the x plus 2. Doesn't matter. Well, here I'm going to distribute. I'm going to get x cubed minus 2x squared plus 7x squared minus 42x. Okay, I can combine some like terms, so my final answer would be x cubed plus 5x squared minus 42x divided by, and then I'm going to get x plus 2, x minus 6, and x minus 2. Now if you notice, I can factor an x in the numerator. But if I factor an x out and have x times this a trinomial, you know, x squared plus 5x minus 42, the x's can't reduce with anything in the denominator. So typically, we always leave the denominator factored, and the numerator we can factor if it's going to simplify. So, but since nothing's going to factor out or simplify out, we can just leave your answer like this. In our last example, okay, I'm going to kind of do a little bit of a shortcut. I look at my denominator here, x plus 1. I can't factor that anymore, so I'm going to leave it as x plus 1. My second denominator I can write as x plus 1 times x minus 6. And in my last denominator, can't be factored anymore. I get just an x minus 6. So what is my least common denominator going to be, my LCD? Well, how can you do without, you know, writing that whole thing out? Well, I like to look at the first denominator, and I know I have a factor of x plus 1, so I need that. Then I look at my second denominator. I need an x plus 1, which I already have written down, but I also need an x minus 6. Then I look at my last denominator. I need an x minus 6, which I already have, so this would be my LCD. Okay, so what could I do? I'm going to start writing it here, just save a little space. I know my LCD is an x plus 1 and an x minus 6. Okay. So how can I do this now that instead of writing each of the fractions out independently with a common denominator, I know that this is my least common denominator, so I'm going to get one fraction. So what I like to do is I have a 1 here, and I look and think, what was I missing from this denominator for my LCD? Well, I was missing an x minus 6, so I need to multiply. If the denominator all of a sudden gets an x minus 6, my numerator needs an x minus 6. Now, I have a minus sign here. Anytime I see a minus sign, I get worried that students are going to make a mistake because they always forget to distribute. So my best suggestion is to take this minus, change it to a plus sign, and then distribute that negative to everything in the numerator. Okay. Now think of this as negative plus a negative 5x plus 2. So what am I missing from my denominator from the LCD? Nothing. So my numerator just stays negative 5x plus 2. Okay. And then my last fraction says plus x, and then I'm missing a factor of x minus 1. Okay. So now this is what my fraction is going to be. I'm just going to try to clean it up a little bit by combining like terms. We typically leave, again, the denominator factored, so once you get your LCD, just leave it. If I multiply x minus 6 times 1, I get x minus 6. I'm still left with the negative 5x plus 2. And if I distribute the x, I get plus x squared minus x. Okay, I'm just going to combine like terms and put it in descending order. So if I look at my x squareds, I only have a positive x squared. If I look at the x's, I have a positive x, a negative 5x, and a negative x. Well, x minus 5x is negative 4. Negative 4 minus x is negative 5x. And if I look at my numbers, I have a negative 6 and a positive 2, which gives me a negative 4. Leaves me with x plus 1, x minus 6. Okay, so if I look at the numerator and try to see, can I factor this possibly? Well, two numbers that multiply to give me 4 but add to give me 5 would be a 1 and a 4. However, there's no way to deal with the signs to get a negative 4 when I multiply and a negative 5 when I add. So this would be my final answer, because it's prime on the top. And now I've been able to combine those three fractions to 1. Okay, the last thing that you're going to come across that could be a little bit tricky is when you have denominators that you can't really factor anymore. It doesn't look like you can factor anymore, but they're reversed. Okay, and what I mean by reversed is this is a positive x, this is a negative x, this is a negative 2, this is a positive 2. So they are the exact same numbers, but the signs are reversed, positive to negative. So what's a way you can deal with this? Because a lot of students either think they're the same or think you can't do anything. So the first thing I want to do is make them look like the same order. We're used to x being first. So if this is a negative x, and this is a positive 2, I could rewrite this to look like negative x plus 2. But what can I factor out of this? Well, most people think you can't factor anything, but you can always factor out a 1 or always factor out a negative 1 in this case. So if I factor out a negative 1, remember when you factor out negative 1, all it does is change the sign. So this is going to be an x minus 2, because if I distribute, I'm going to get a negative x plus 2, which is the same thing as 2 minus x. So I didn't change anything, I just changed how it looked, but I didn't change the value. So now I have an x minus 2 here, and now I have an x minus 2 here. So this factor would be an x minus 2, and this factor would be a negative 1 times an x minus 2. So now, instead of thinking you have two separate things which can make your problem longer, both already have an x minus 2. The only addition you would need is a negative 1 on this side to get a common denominator. So it's a nice little algebraic quote-unquote trick, even though it's not really a trick, but it's a way to help you make things that do not look like they're common and like terms by just factoring out a negative. Well, I hope you feel a little bit better about adding and subtracting rational expressions, being able to simplify rational expressions, and then being able to simplify rational expressions that include addition and subtraction.